Hello everyone. Today is December 20. We are ready to discuss a new problem from LeetCode for our Coding Advent Calendar. Don't forget to press the like, share, and if you have any questions or you can correct me, please leave the comment. Let's begin. Here is today's problems. Keys and rooms. There are n rooms labeled from 0 to n-1, and all the rooms are locked except for room 0. Your goal is to visit all the rooms, however you cannot enter the locked room without having the key. When you visit a room, you may find a set of distinct keys in it. Each key has a number on it, denoting which room it unlocks. And you can take all of them and you can unlock the other rooms. Given array of rooms, where a room I is a set of keys that you can obtain from the visited room I, return true if you can visit all the rooms, or false otherwise. So here is example. There is an array of 4 rooms. In room 0 we can find key for room 1, in room 1 we can find the key for room 2, in room 2 we can find the key for room 3, and we can unlock the room 3. So, and this is another example, and there is no way we can unlock room 2 because the key for room 2 is only inside the locked room 2. How are we going to solve this problem? So let's rephrase it. We need to return true if we can visit all the rooms, right? Let's do the different definition. We need to return true if we can collect keys for all the rooms, right? How can we identify that we collected all the keys? We need to store a distinct set of keys, and in the end of the algorithm, when we're done visiting all available rooms, we need to check that the number of rooms is the same as the number of keys, distinct keys. Since rooms are distinct by definition because they are defined by indices in an array, we can compare these two counts and lengths of array, and that's how we can check if we found all the keys. So we need to have a data structure to store distinct keys, and in order to do this we are going to use hash set. Okay, what are we going to do next? We need to have two separated sets of keys. Some keys are already used to open doors, some keys are not. So we need to store keys which are not used yet, right? And we are going to do this by using a different data structure, a queue. Since we need to add keys to this set and take keys from this set, we can use a data structure like linked list or stack, but I prefer queues. I don't like queues, like queues in cafeteria, for example. So the definition of problem states that room 0 is unlocked, This is equivalent of the definition that room 0 is locked, but we have a key for it. And we are going to define this by adding keys at 0, and we will also enqueue this 0 to the queue. And since we have our queue non-empty right now, we can start our algorithm while queue count is more than 0. We are going to do the following. We can take this key from the queue, and this key opens some door, right? And let's define this variable as door. And we open this door and we check what keys are behind this door, right? What are we going to do next? If we found a key which is already in our set, we just throw it away. We just continue with the next key. If we found a new key, we need to add it to our set of keys, right? And we also need to add it to a queue of keys which are not used yet. That's it. So, using this algorithm, we are going to add new keys to a queue, and we will dequeue these keys and open new doors. Once we have our queue empty, that means we don't have any keys which are not used yet, so we cannot open new doors. That means we need just to check that return keys count equal to rooms count. That's it. Both cases are passed. And we have pretty good result. So let's discuss the complexity of this algorithm. The time complexity is big O of n plus m, where n is the number of rooms and m is the number of keys inside these rooms. Because, for example, we can have rooms and all the rooms contains keys for all other rooms. And the time complexity is big O of n, because we need to store only distinct number of keys, and we have a queue with which is also big O of n, so the memory consumption is big O of n. That's it. It is simple actually. It's not medium. I don't know why it's stated as medium, but it's popular question when you have interviews in companies like Amazon, Google and Microsoft. That actually was an easy one. Don't forget to solve tomorrow's problem before me, so when a new video comes out, you can compare your solution with mine. See you tomorrow.